This is paper 3, video 2 for the February mock. So the first topic we're going to look at on this video is all to do with error intervals. Now the error interval is simply a way of writing down the upper and lower bound as an inequality. So the first thing we need to do on each of these is work out what the upper and lower bound, so the maximum and minimum, that each of them could have been if they'd been rounded to the given degree. So 20 grams measured to the nearest gram. My way of thinking about this is whatever it's been rounded to, so in this case the nearest gram, if you half that, so 1 gram, half of a gram is 0.5 grams, the upper bound and the lower bound are then 0.5 grams above and below what we started with, the 20 grams. So the upper bound would be 20.5 grams and the lower bound 0.5 less than 20, so 19.5 grams. Now to change this into an error interval, what we write is 19.5 and 20.5 with a little x in the middle. We then need some inequality symbols. Now if I'd rounded 19.5 to the nearest gram, it would give us 20. So we put a little less than or equal to inequality symbol there to show that x could be everything all the way down to 19.5 and bigger. However, for the 20.5, if we tried to round 20.5 to the nearest gram, that would have gone up to 21. So what we say is that for the error interval, we want everything that is less than 20.5 but not quite 20.5. So this little section in the middle does not change whenever we do error intervals. For the next one down, because we're rounding to the nearest £10, I'll take that £10 and half it, which is 5. So the upper bound and lower bound will be £5 more and £5 less than what we started. So the upper bound would be £445. The lower bound is £5 less than the 440, so 435. And then as an error interval, we would have 435 and 445 written down. The inequalities never change. For the lower bound, it could be included. The upper bound, not quite, so it's everything less than that. So same idea with the last question here. To the nearest kilogram, so 1 kilogram, half it would be 0.5 of a kilogram. So our upper and lower bound is 0.5 above and below the 63, so 63.5 and 62.5. And these will be the two numbers that we use for our error interval. So 62.5 less than or equal to x, just as above, less than 63.5. And your error interval will always be in this form. Lower bound, less than or equal to x, less than the upper bound. This is the next question we're going to look at, so it's a little bit to do with probability. We've got some fractions in here. So this is another type of question that they love to put on the exam nowadays, where there's a lot of information, you have to try and decipher what it wants us to do. So if we try and take each line at a time, there are 180 pupils in a Year 10 form, or Year 10 group. 7/10 are girls. So the first thing I'm going to do is 7/10 of 180. Just remember, 180 divided by 10 times 7. You've got a calculator to use on this question if you need to. That gives us 126, and that's the number of girls. I've not been told to find it, but just at that point, if I know there's 126 girls, to find the number of boys, I take the pupils in the year group, take away 126, which gives us that there are 54 boys. Next line down. The probability of a boy chosen at random eats in the school canteen is 4/9. Well, 4/9 simply means that 4/9 of the boys eat in the school canteen. So 4/9 of 54 eat in the canteen. 54 divided by 9 is 6, times 4 is 24, so there's 24 boys in the canteen. Again, it's not asked me to work this out, but sometimes it's just worthwhile working out little numbers when I can see that I can do it. If I know 24 boys eat in the canteen, 54 boys altogether, quick little calculation here, of 54 take 24 tells me that 30 boys do not eat in the canteen. Always a good idea to try and label what you are doing as well, because it's very easy to get confused with what numbers you've calculated and what each little bit tells us. Next line down on the question says 4/5 of all pupils in year 10 eat in the canteen. So let's work that out. So 4/5 of all of the pupils, so 4/5 of 180. Again, you've got a calculator. In order to do 180 divided by 5, times that by 4, it tells us 144 pupils in the canteen. And again, it's not asked me to work this out, but at that point, I'd very quickly just think, well, if 144 eat in the canteen, that tells me that there must be 36 not in the canteen. So the final line of the question says, what is the probability that a pupil chosen at random is a girl that does not eat in the school canteen? Now I think that's the only number I've not worked out so far in all of the calculations. So if we've got that 36 pupils do not eat in the canteen, there are 30 boys that don't eat in the canteen. So to work out the number of girls that don't eat in the canteen, 36, that's all the pupils that don't eat in the canteen. I must do something else. 30 of them are boys, so it leaves 6 girls not in the canteen. So if I wanted to write that as a probability, there are 6 girls altogether that don't eat in the canteen. There are 180 pupils in the entire year. So the probability of picking a girl not in the canteen must be 6 out of 180. Or, if you want to simplify, that would give us 1/30. The next topic is all to do with solving equations. This time though, all the equations have letters on both sides of the equation. Now, in order to try and stop that being a bit of an issue, the first thing I would always do with these sorts of questions is try and make it so that the letter only appears on one side of the equation. The way I normally do that is look at seeing which side has the smallest number of letters. In this first case, it is x. So what I want to do is I want to move and get rid of that x. I'm going to do that by taking x away from both sides. Remember, you've got to balance equations. So if I take x away from the right hand side, it leaves me 70. If I take an x away from this side, it will give me 2x minus 30. I'm now going to solve just like a normal equation. So I'm going to add 30 to both sides to give me 2x is equal to 100. Dividing both sides here by 2 will give me that x is equal to 50. The next question, I'm going to do the same thing. We've got 2x and 7x. Well, 2x is the smaller this time, so I'm going to take 2x away from both sides of the equation. That would leave me 6 on the left, because the 2x has gone. Take 2x off this side will give me 5x plus 1. In order to solve a question like that, we would have to take 1 away from both sides. So I'm trying to leave x on its own. So if I take 1 away, I get that 5 is equal to 5x. So here I'd just divide both sides by 5 to give me 1 is equal to x, or if you prefer, x equals 1. I'd take 3x away on this question, because 3x is smaller than 6x, so taking 3x away from both sides would give me 3x plus 2 on the left, 15 on the right. I'd now take 2 away from both sides to give me 3x equals 13. And the last bit, to try and get x on its own, I'd have to divide by 3. Now I've run out of space here, so we'll just do it over this side. Divide by 3. Now you can either do that on your calculator, or we need to divide by 3, so I could just write 13 over 3. You'd also be okay if you wrote 4.3 recurring. Do not, however, write 4.3 because you haven't solved it accurately. The last question, same idea. We've got 4x and x. Well, x is smaller, so that's the one I'm going to move. So if I take x away from both sides, it will give me 3x minus 11. And that would be equal to, be careful here, if I take the x away, it leaves minus 35. I would then have to add 11 to both sides to try and get rid of that minus 11. So that will give me 3x is equal minus 35 plus 11, so I'm going up 11, that would get me to minus 24. And then divide both sides by 3, so you give me that x is equal minus 24 divided by 3, gives us minus 8.